All right, so I'm going to do a problem that deals with a confidence interval for a proportion. So our problem, in the problem we're given a random sample of size n is 131, yielded p hat of 0.88. So question one, is a sample large enough to use the large sample confidence interval for a proportion? Well, we have two criteria for that. We need n times p hat has to be at least 15, which means that 131 times 0.88, find out what that is in a minute, and we need n times q hat to be at least 15 as well. And note q hat equals 1 minus p hat. All right, so that's 131 times 1 minus 0.88 is 0.12, so that's our q hat. So let's calculate these two things. So using the calculator, 131 times 0.88. And we might as well do the other one. 115.28 is certainly large enough. 131. Using Q hat, we get 15.72, which is also large enough. So let's write that in. That's at least 15, as is 15.72. So N is large enough. Okay. Now we want to calculate a 90% confidence interval for P, our proportion for the population. And we're going to use the appropriate calculator function. Well, I've got the appropriate calculator function written up top. One PropZInt means that it's a proportion. There is one proportion. We're using the Z distribution, and int is short for confidence interval. So in order to get there, we go stat tests one PropZInt. Okay, so let's do this on our calculator. Stat, arrow over to tests, one PropZInt. I don't see it on this page, so let's scroll down until we find it. We don't want one PropZ test. That's a test of hypothesis. So one PropZInt is the letter A on mine. If you're using a different calculator, it might be something else, maybe 0 or something like that. I'm not sure. So let's see what it wants. It wants X, N, and the confidence level. Well, we know N. N is 131. The confidence level will also be 0.95. So let's try to figure out what X is. Note that P hat equals X over N. And that means, well, we've got two of those things, right? So that's 0.88 is P hat, and that equals X over Rn. In this case is 131. So that means X equals 131 times 0.88, which we can see above. And let me put a box around it. This equals 115.28. You can also do that in your calculator. So let me do the multiplication in the calculator. 131 times 0.88. So I get that 115.28. Now, if you try to leave that number in there, it's going to cause a problem because it's looking for a whole number. X is a number of successes. You can't have you can't have 0.28 of a success. So we're going to need to round this number, at least for the calculator's sake. If we were looking at this, and well, I mean, in all actuality, this number is going to be rounded anyway. Our X should be 115. So in essence, 0.88 has been rounded. The actual number will be shown in a moment. All right, so N is 131. We want a 90% confidence interval, so this is going to be 0.9. And now we calculate, and this up there is our interval. So we have 0.831. So our 90% confidence interval goes from 0.831 to 0.925. Notice p hat is actually 0.87786, which has been rounded to 0.88 in the problem, but our n still outputs at 131. And this is how you do a problem on the calculator.